Hi, Geometry. Welcome to the last lesson of Unit 3. We are now making the jump from what we did yesterday to how it applies to parallel and perpendicular. So explaining how the slopes of parallel lines are related, as well as the slopes of perpendicular lines is the learning target, and determining whether two lines are parallel, perpendicular, or neither using slope. All right, so parallel lines have the same slopes. Should remember that from Algebra 1. Perpendicular lines have opposite and reciprocal slopes. Okay, so what does that mean? So let's say we have 3 over 2. The opposite reciprocal of 3 over 2 would be negative 2 over 3. It's the opposite sign, and the fraction is flipped. Okay, so first two examples. Tell whether the pair of lines is parallel, perpendicular, or neither. I'm actually going to type this because it's too much writing. All right, I'll write what they are. So what we want to do is look at their slopes, right? So we want to look at their slopes. The slope of the first one is 1/2. The slope of the second one is 2. This one was easy because they were already in slope-intercept form. These lines are neither. Why? This is where I'm going to start typing. The slopes are not the same. If they're not the same, then they're not parallel. Okay? They are also both positive, right? So they can't be perpendicular. Right? If they're both positive, they're not opposites of each other. Yes, they are reciprocals, but they're not opposites. Go ahead and delete that. If you didn't get that written down, rewind the video a little bit and watch that again. Okay. Next one, not as easy because one of them is in standard form. So I know the second one here has a slope of negative 3/5. Okay. First one, I need to subtract 5x. This is from the lesson yesterday and from Algebra 1. So that's negative 3y equals negative 5x plus 9. Divide by negative 3. So I get y equals negative divided by negative is going to be positive 5 over 3 x minus 3. So the slope of this one is 5/3, negative 3 over 5. These lines are perpendicular. Why? Okay, now be careful here. I'm going to caution you. I've seen people do this all the time. I hear people say they are opposite reciprocals. What's they? Make sure you put the slopes are opposite reciprocals of each other. Okay. If you just say they're opposite reciprocals of each other, you're not really being specific enough to get the point there. You have to understand the slopes that have to do that. Okay. So that's determining whether they're parallel or perpendicular. Go ahead and delete all that and move on to the last little bit of these notes. Writing the equation of the line. Now that seems like I'm almost done with the notes. I'm actually going to spend probably most of my time here. All right. So write the equation of the line that is parallel to y equals 3x minus 1 that goes through this point. I'm not going to do this. I'm not going to expect you to do this, but I'm going to show you what's going on here. So I'm going to graph this, go down to 1, and then from there I go up 3, right 1. So that's the line that I was given. Negative 2, 6 is way up here. It's definitely not on the line. What I want is I want the equation of the line that's dotted here. I want the equation of the line that's parallel to the solid line, but it goes through that point. Okay, so how am I going to do that? Well, I need to find the slope first, just like we did yesterday. Find the slope first. Find the slope of the line that you will be using. So what is the slope of the given line? So first thing you want to do is find the slope of the given line. So the solid line, right? The slope of the given line is given to me, actually, it's 3. The slope is 3. So then what's the slope of the parallel line? Okay, PAR, parallel. Well, if you understand that slopes of parallel lines are the same, you know that the slope of the parallel line is also 3. And then what you can do is just put the slope in there for 3. Now the y-intercept, a lot of people put -1 here, or they put 6, because that's the y value. Don't do that. You're looking for the y-intercept, which is way up here somewhere, right? How do I get that? Change colors so I don't run into everything here. We talked about this yesterday. We have the slope. We have the point, right? The point is -2,6. So I'm going to go, there's 2 ways of doing this, but I'm going to do it the way that I teach it in my algebra classes. Y equals mx plus b. The y value is 6. The m we just found was 3. The x is -2. And b is unknown. Solve it for b. I get 6 equals -6 plus b. Add 6 to both sides. I get 6 plus 6 is 12. So 3x plus 12. And that makes sense. I said the y-intercept is somewhere way up here. 12 makes sense. Okay. Last one, write the equation of the line that is perpendicular to that line that goes to that point. So it's a very similar question, but there's a little more work involved on this one for a couple different reasons. First reason is the slope's not as easy to find. It's in standard form. I need to find the slope first. So subtract 4x first. And I get -2y equals -4x plus 17. Divide by -2. Divide by -2. Divide by -2. I get y equals negative divided by negative is positive. 4 divided by 2 is 2, so positive 2x. 17 divided by -2 is not a good number, but I don't really care. I don't really care what that number is because all I want is the slope here. The slope is 2. Now, be very careful. I said that there's a couple reasons why this is a little bit harder. The first reason is you had to find the slope. You had to do all that work. We're still not even at the point where we were on the previous example. The second hard part is you can't put 2 in for the slope. I see a lot of people just, oh, put the 2 here. Don't do that. That's the slope of the solid line. Like if I were to graph this, this is the solid line. I don't want the solid line. I want the slope of the perpendicular line. Well, what is that? Well, this is where you have to understand that you have to take the opposite reciprocal. So 2 as a reciprocal is 1/2. Those are both positive. My slope has to be negative. So this is -1/2 for my slope. And that's the slope I need to use. Now I go back and find b by using the point. So y equals mx plus b. The y value is -1. The slope is -1/2. The x is 8. And b is what we're looking for. -1/2 times 8. Well, 1/2 times 8 is 4. -4 would be that. And then to get b, I'm going to add 4 to both sides. -1 plus 4 is 3. There's my equation. Okay. I know that I'm going through that pretty quickly. Watch it again. You've done this before. You did it back in algebra. Okay. So it's not anything new. And I know it, but I know it's challenging. We'll work on it though in class. So come with questions.